cancer, you would want to be sure if it is probably true. A hypothesis test will tell you if it's probably true or probably untrue. A z-test is used when your data is approximately normal and highly distributed. So what is z-score? The standard score, more commonly referred to as z-score, is very useful statistics because it A. allows us to calculate the probability of a score occurring within a normal distribution, and B. enables us to compare two scores that are from different normal distributions. The standard score does this by converting scores in a normal distribution to z-scores in what becomes a standard normal distribution. So when do we run the z-test? Several different types of tests are used in statistics. You would use a z-test if 1. Your sample size is greater than 30, otherwise use a t-test. 2. Our data should be normally distributed. And 3. Your data should be randomly selected from a population where each item has an equal chance of being selected. How to run a z-test? Running a z-test on your data requires 6 steps. 1. State the null hypothesis and alternative hypothesis. 2. Choose an alpha level. 3. Find the critical value of Z in a Z table. 4. Calculate the Z statistics. 5. Compare the test statistics to the critical Z value and decide if you should support or reject the null hypothesis and the plot of graph. And 6. Draw the conclusion. So let's have 3 examples for the
Problem number 1. The hospital record shows that the mean weight of newly born babies is 7 pounds. With a standard deviation of 0.75 pounds, our researcher takes a sample of 55 newly born babies and found to have a mean weight of 6.73 pounds. Does the sample taken significantly differs from the mean weight? Test the claim at 0.05 level of significance. We can first start off by writing the given. Mu is equals to 7 pounds. Standard deviation is equals to 0.75 pounds. N is equals to 55. And X bar is equals to 6.73 pounds. Now, step 1. State the hypothesis. The null hypothesis in the problem is mu equal to 7 pounds. That makes our alternative hypothesis mu not equal to 7 pounds. We use an equal and non-equal sign since it is a two-tailed test. Step 2. Level of significance. The level of significance in the problem is 5% or 0.05. It is a two-tailed test because we want to know if there is a difference at the mean weight. Step 3. Locate the z-score at the t-table knowing that the level of significance is 0.05 and is two-tailed. The z value is positive, negative 1.960. Step 4. Computation. Using the formula z is equals to x bar minus mu over standard deviation over the square root of n. Substitute the given data to the formula and simplify the equation. 6.73 minus 7 over 0.75 over the square root of 55. The answer should be negative 2.67. Box your answer. Step 5. Graph. To graph, draw a normal curve and first plot the z value, which is positive and negative 1.960. Shade the parts to indicate that this part is the rejection area. Now draw a line to the point negative 2.67. The line is located at the rejection area. Now we can support the claim. We accept alternative hypothesis and reject the null hypothesis. Step 6. Conclusion. Since we reject the null hypothesis and accept the alternative hypothesis, we can conclude that the sample taken significantly differs from the mean weight. Now let's get on to the next problem. Problem number 2. An economist claimed that the mean family income of a certain populated area in Metro Manila is at most 22,450 pesos monthly. The economic students take a sample of 150 families, obtaining a mean of 21,555 pesos with a standard deviation of 1,253 pesos. Does the data provide enough evidence to support the economist's claim? Again, starting off with a given, mu is equals to 22,450 pesos, n is equals to 150, x bar is equals to 21,555 pesos, and standard deviation is equals to 1,253 pesos. Now step 1. The null hypothesis in this problem is mu equal to 22,450 pesos, and our alternative hypothesis is mu not equal to 22,450 pesos. Again, it is a two-tailed test because we want to know if there is a difference. Step 2. The alpha, or the level of significance in the problem, is 0.05. It is a two-tailed test. Step 3. The z-score, or the z-value, again, same as the problem number 1, z is equal to positive and negative 1.960. You can locate it at the t-table using the level of significance. Step 4. Computation. Z is equals to x bar minus mu over standard deviation over the square root of n. Now substitute all the values to the formula. 22,555 minus 22,450 over 1,253 over the square root of 150. Your answer should be negative 8.75. Step 5. Draw a normal curve to graph and plot the values positive and negative 1.960. Again, shade the parts to indicate that this is the rejection area. Now plot your point, negative 8.75. We accept the alternative hypothesis and reject the null hypothesis. Step 6. Conclusion. Since we reject the null hypothesis and accept the alternative hypothesis, we can conclude that the data does not provide evidence to support the claim. Last problem. Problem number 3. A health researcher read that a 200-pound male can burn an average of 524 calories per hour playing badminton. 37 males were randomly selected and the mean number of calories burned per hour playing tennis was 534.8 calories, with a standard deviation of 45.9 calories. Do tennis players burn more calories than badminton players? Test the claim at 0.01 level of significance. Write the given data. Mu is equals to 524. Standard deviation is equals to 25.9. And our sample size is equals to 37 and x bar is equals to 534.8. Now step 1. Our HO or null hypothesis is mu greater than or equal to 524. And our HA or alternative hypothesis is mu less than 524. Now step 2. The level of significance or the alpha of the problem is 0.01. It is a one-tailed test because we want to know if tennis players burns more calories or greater amount of calories than badminton players. Step 3. Locate the z-score again at the t-table, and using the level of significance of 0.01, you should be able to get z is equal to negative 2.326. Now step 4. Computation. Using the formula z is equals to x bar minus mu over standard deviation over the square root of n, and substituting all the data to the formula 534.8 minus 524 over 45.9 over the square root of 37. The answer you should get is positive 1.43. Step 5. Graph. Draw a normal curve and plot the z-score negative 2.326. Now, plot or draw a line to the point 1.43. The line or the score is at the rejected area, therefore, we reject the alternative hypothesis. Accept HO and reject HA. Step 6. Since we accept the null hypothesis, we cannot conclude that the tennis players burns more calories per hour than badminton players.
That's all for the one sample z-test. I hope you learned how to solve problems using z-test. Now let's get on to the next topic.